Alright, so this is an example that I borrowed from our textbook. So I would like to go over this example. So in a photographic process, the developing time of prints may be locked upon as a random variable having a normal distribution with mean 15.4 seconds and standard deviation of 0.48 seconds. Find the probabilities that the time it takes to develop one of the prints will be at least 16 seconds. So before we attack the first part, let's define what we are dealing with. So I'm gonna define my x to be the developing time. And based on the given fact in the problem, we know this follows normal distribution with mean 15.4 seconds and standard deviation of 0.48. Okay, so I'm gonna put this way. Right, so the part A is asking what is the probability that the developing time being at least 16 seconds. 16 seconds. So we formulate that way. So again, we are going to transform this random variable, this normal random variable x, through its mean, 15.40 by shifting by its mean, and its standard deviation of 0.48. And we do the same shifting and rescaling this way. Then this probability is, so let me remind you, point of doing this is once we shift transform that way, we know this follows standard normal distribution. So this is going to be standard normal being greater than, and this value is going to be, this value is going to be 1.25. So this is the same as standard normal being 1.25. And once you get to standard normal probability calculation, I highly suggest you to draw a picture, bell-shaped picture with mean 0 as a reference point. And this probability is telling us to get probability of z, probability of standard normal z being greater than 1.25. So it's going to correspond to this area, right? But from our table, we know we can get probability something looking like that, right? And then we know area on the right side of this curve all the way up to infinity is 0.5. So what I'm going to do is I'm going to manipulate this probability in a way that minus probability of z between that given value. So what I did is, in order to get, look at the screen, this part, probability for this part, what I'm going to do is I'm going to get probability for this entire half, 0.5, and subtract by the probability corresponding to this empty part, which can be written in terms of this probability statement, z being between 0 and 1.25. Why am I doing that? Because this probability z being between 0 and 1.25 can be easily read from the probability table. Right, so I'm gonna get you to the probability table, normal table. Okay, so it's over there. So what we need is probability of standard normal being between 0 and 1.25. So on the column, the first column, it is giving the z value up to the first decimal, and we need actually z value up to the second decimal, 0.5. So 1.25. So you follow this row and stop at the second decimal being 5. So this probability corresponds to the probability z between 0 and 1.25. So 0.3944. Okay, so let me get to the original slide, and this is 0.5 minus, we just found out that the probability is this, so this is 0.1056. Okay, next up is the probability x being at most 14.2 seconds. So let me state that here, probability of developing time x being at most 14.20, so which is going to be probability of x minus 15.4 because it is the mean of x, and divide by 0.48, which is the standard deviation of x, and same shifting and scaling. Okay, then again we know this quantity is going to be a standard normal distribution, standard random variable, standard normal variable, and the quantity on the inequality is negative 2.5. Again, it is time to draw a picture just to think about the strategy to use the table. Okay, so in this case we are looking at the probability of standard normal being less than negative 2.5. Okay, so we are going to use the symmetry of the standard normal distribution. So let me draw the copy, just copy the density curve I just draw, and because of the symmetry, probability, so look at the curve, probability of z being less than negative 2.5 is exactly the same as probability of z being greater than 2.5. Okay, and why am I doing this? Because we can easily read this probability z being between 0 and 2.5. So what I'm gonna do is I'm gonna restate this probability using symmetry of the normal distribution and read this highlighted probability from the table. Okay, so why don't you pause and read the probability yourself and see if that is the same as my answer. So pause it. I guess you're back, right? So it is 0.5 minus z being between 0 and 2.5 is 0.4938, so which gives us the probability of 0.0062, which is very small, and we can kind of get why that is small because we're looking at the end tail probability. Okay, right, next up is what is the probability that developing time being anywhere between 15 and 50.8 seconds. Okay, so we are going to do the same transformation as we've been doing. Z and 50.8 minus 50.4 divided by 0.08. Okay, you can pause if you want, and I'm gonna clean up these values. Negative 0.83, standard normal 0.83, and because of the symmetry, okay, so let me draw a picture first. Again, the same bell-shaped symmetric curve, symmetric at 0, and we are looking at probability of z being between minus 0.83 and positive 0.83, even though my picture is not that symmetric, but we know for sure that these probability on the right side of 0, left side of 0, they are the same. So we can actually rewrite this probability as twice of x being between 0 and 0.83 instead of getting the probability z between negative 0.83 and 0.83. Okay, so this probability z between 0 and 0.8, you can check from the table, that is 0.2967, so that is going to be 4. So I hope this exercise or review is helpful for you, and I hope you enjoy the rest of the lecture video today. Okay, I'll see you soon.